Good morning, dear students. So in the last class, we have seen the preparations of aldehydes, okay, and we have completed the preparations of ketones also, right? Then we had started with the physical properties, right? So we will discuss the further part. So let us see the physical properties. Okay, so we were discussing the boiling point and also we have completed the physical state. Okay, so in the last class, I had given you the data, okay, that is of different functional groups. When you compare hydrocarbons, ethers, right, then your aldehydes, ketones, and alcohols. If you see this, okay, aldehydes and ketones are having slightly higher uh, boiling point. What is the reason? It is due to weak dipole-dipole interactions, right? And the molecular mass of all these functional groups is same. Almost it is same, right? It is 58, 60. We have seen in the previous, I had given you the data, right? So, and when you compare it with alcohol, so when you see it with alcohol, alcohol is having the aldehydes and ketones, okay, they are having a slightly lower boiling point. Alcohols are having higher boiling point, right? So when you compare alcohol, alcohol is 370 of propanol, okay, propanol. And when you see your acetone, okay, acetone is 329, propanol is your 322. Okay, so when you compare these, okay, that is aldehydes and ketones, they are having weak dipole-dipole interaction and therefore their boiling point will be more, okay, as compared to that of the hydrocarbons and ethers. And these are having almost similar molecular mass, okay. And when you compare it with propanol, why propanol is having highest? What was the reason? What is the reason why alcohol is having slightly higher? Yes, because in alcohols there is a strong intermolecular hydrogen bonding, right? They are having strong hydrogen bonding between the molecules. So because of that, alcohols are having slightly higher boiling point as compared to that of acetone and your aldehyde. Okay. When you compare your acetone and aldehyde, okay, that time, so the boiling point is slightly lower as compared to that of your propanol. Alcohol is having slightly higher boiling point. Why? What is the reason? It is due to the presence of strong hydrogen bond. Okay, so these things you have to keep in mind. Okay, next is, uh, okay, before that, if I tell you, now I'll give you something. Okay, suppose I have these compounds, okay, CH3, CH2, CH2, CH4, okay, then I have CH3, OH, then I have C2H5, O, C2H5, then I have CH3, CH2, 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 CH3. Okay, so I have one aldehyde. Okay, I have one butanol. Okay, then I have one butanol. I have one diethyl ether. Okay, and I have one pentane. Okay, so which will be having high, you have to arrange this compounds, okay, in increasing order of boiling point. increasing order of boiling point. How will you say? So I'll name it as A, B, C, and D. Yes. So which will be having the lowest boiling point? Increasing means from lower to higher. Okay. So which will be lowest boiling point? Which compound will have the lowest boil? This. So the last one is a hydrocarbon. Okay. So when you compare your, yes, which will have the lowest boiling point. So first one is your aldehyde. Okay. Second one is your alcohol. Third one is the ether. Okay. Fourth one is the hydrocarbon. So in the previous class, we have seen, I have given you the table. I have told you how the boiling point increases, right? How it affects based on the functional groups. Yes. Now, when you compare, so almost these compounds, they are having similar molecular mass. Okay, they are having almost similar molecular mass. But as you see, in case of your hydrocarbons, okay, so this will be the lowest. So when you want to arrange in the increasing order of boiling point, first will be your third one. Okay, the compound third, that is your pentane. So it will be the lowest. Okay, it will be the lowest. Then will be your what? Then will be your ether. Okay, then will be a ether. Then between your aldehyde and keto alcohol, your aldehyde. Okay, and alcohol will be having the highest boiling point. Alcohol will be having the highest boiling point. Okay, why? What is the reason why alcohol is having the highest boiling point? The reason is that it is due to the fact that there will be presence of a strong hydrogen bonding. Okay, due to the presence of strong hydrogen bond. Fine. Next is solubility. Next, we are going to discuss about solubility. What do you mean by solubility? Solubility means how best it can get dissolved in, whether it is in water or in your organic solvents. Okay. Now, lower members of these aldehydes and ketones. Okay, the smallest members like your acetaldehyde. Okay, formaldehyde. So these your compounds, that is the lower members, methanol, ethanol, propanol. Okay, so these are miscible in water. Miscible means they can get mixed in water. Okay, they can get dissolved in water. Okay, they'll get dissolved or they get mixed in water in all proportions. So in any proportions, if you take, in any amount, if you take your aldehyde ketones, okay, and then they are completely soluble in water. Why? What is the reason? Because they form the hydrogen bonding with water. Okay. The reason is that they form the hydrogen bonding. We know that hydrogen bonding is formed when you have a electronegative atom present. Okay. Whenever you have, now you have what here? You have a aldehyde. Okay. So oxygen is a highly electronegative atom. Right. Oxygen is a highly electronegative atom. So when you add this aldehyde into water, what will happen? Yes, what will happen? So there will be, suppose this is a water molecule. So there will be intermolecular hydrogen bonding formed between the highly electronegative oxygen atom of the aldehyde group and the hydrogen atom from the water. So like this, they form the intermolecular hydrogen bonding. So because of this property, your lower aldehydes and ketones are highly soluble in water. Okay, because of the presence of these polar groups. Because there is a presence of this polar carbonyl group. Polar carbonyl group, okay, it can easily get polarized. So this is partial positive, this is partial negative, right? So because of the presence of partial positive and partial negative, that is a polar carbonyl groups, they form the hydrogen bonding with water. Okay, so this is the about the solubility. Okay. However, if the solubility of aldehyde and ketones decreases, so as you go to the higher aldehydes and ketones, okay, as you move to the higher aldehydes and ketones, what will happen? There will be increase in the length of alkyl chain, right? Molecular mass will increase, or you can see there is increase in the molecular change. The number of carbon atoms are getting increased, okay, as you go from lower to higher. So what will happen? The solubility of these aldehydes and ketones will start decreasing. Okay, the solubility will start decreasing. And when you talk about ketones, ketones are fairly soluble in organic solvents. So they can get dissolved in your benzene, ether, methanol, and chloroform. So this was all about solubility. Next is odor. Odor means smell. Okay, how does these aldehydes and ketones, how they have the smell? Okay. So whenever you see the lower aldehydes, okay, whenever you have a lower aldehydes, they have pungent smell. So I've mentioned it in the last class. Pungent smell means bad smell. So they have a very bad smell when you have a lower aldehydes. Okay. As the size of the molecules increases, what will happen? The smell goes on decreasing. The bad smelling, it goes, okay, and it becomes more fragrant. So as you go to the higher aldehydes, the bad smelling, it will reduce and you will get some good fragrance for the aldehydes. So many naturally occurring aldehydes and ketones, they are used in blending of perfumes and flavoring agents. So aldehydes and ketone, most of these, okay, they are naturally used for making up of perfumes and some flavoring agents. So this was about the next physical property. Okay. So next we are going to discuss about the chemical properties. Okay, next we are going to start with the chemical properties. Physical properties, we have said physical means what? It tells you how physical appearance, okay, about the physical appearance. How the aldehydes they smell, okay, how they appear, whether they are, what is the state of those, okay, like that. Then basically their melting point, boiling point, how, whether it is soluble in water or no. So these are some basic physical properties. Chemical properties means what? Chemical reactions, or chemical properties means how they react. Okay, how the aldehydes and ketones will react with the other things. Okay, so chemical reactions. So when we are discussing about aldehydes and ketones, they undergo nucleophilic addition reactions. Okay, they undergo nucleophilic addition reactions. Okay, so how this nucleophilic addition reaction takes place, we are going to see the mechanism. Very important. We are going to see the mechanism. So you can see this is a your aldehyde or ketone. Your carbonyl group is present here. So what we'll done? So we have taken a carbonyl group. As you know, carbonyl group is what? Highly polar group, right? It is highly polar group. As a result, there will be partial positive charge developed on carbon and partial negative charge developed on oxygen, right? So what will happen? This is in a planar. So this is the planar molecule. If I compare the molecule, okay, and if I keep it on a plane surface, okay, carbon is in the center, oxygen is here one bond, here one. Okay, so it is in a plane. It is in a plane. Okay, so it is sp2. The hybridization of the carbon is sp2 because you have a double bond here. Now what will happen? The nucleophile will attack. So nucleophilic addition means nucleophile should attack. Nucleophiles are what? Nucleophiles are electron rich. Okay, electron rich species, they are called as nucleophiles. So what happens here? The nucleophile will attack the sp2 carbon of the carbonyl group from directing, okay, from the direction perpendicular to the plane. So nucleophile will attack from this end. Okay, this will attack to the direction perpendicular to the plane. Now this is a plane, so attack takes place from this side. Okay. So what happens during the hybridization when the nucleophile is getting attacked? So the hybridization of the carbon, it changes from sp2 to sp3. Okay, it changes from sp2 to sp3. Why? Because now there is a nucleophile attack. So your oxygen will get polarized. So as a nucleophile will attack, the carbon bond will get polarized. So it is like this. Okay, if I want to write it, it will be like this. So this is your plane this. So nucleophile. Okay, so nucleophile will attack the carbon. So as a result, there will be development of partial charges, and this will get polarized. So this here it was sp2 hybridized. So what will happen here? So it will become, so nucleophile is attacking here. There will be your this, then this, and your oxygen will be minus. So like this. Okay, so this will, what happens to the hybridization of carbon here? It will be sp3. So it undergoes a slow step where you can see the hybridization of carbon changing from sp2 to sp3 in a tetrahedral manner. Okay, you can see the geometry, it is tetrahedral. Okay, now this is a alkoxide ion is formed. Okay, now this alkoxide ion, what it does, it should accept the proton, and it undergoes a fast step to form a alcohol. Okay, so it gives you a so this, it will accept a pair of proton. Okay, and it gives you a addition product. So it gives you an addition product. Okay, so this is the nucleophilic addition reaction. So like this, the nucleophilic addition reaction takes place on the carbonyl carbon, whether it is aldehyde or ketone. So any of this, it will undergo. So nucleophile will attack from the rear side of the carbon, okay, which is perpendicular to the plane. Then the carbonyl carbon will get polarized. So partial, there will be development of charges, partial positive charge on the carbon and partial negative charge on the oxygen. As a result, what will happen? Polarization of bond takes place, and it results into a tetrahedral geometry, okay, where carbon is sp3 hybridized. So hybridization changes from sp2 to sp3. In the second step, what happens? Alkoxide ion, okay. So the attack of a proton takes place, okay. The proton, it accepts a proton, okay, and the addition product is formed. So this is the nucleophilic addition reaction. Is it clear?
Yes, ma'am.
Okay. Fine. So next is the, so when we are discussing upon what is the reactivity of aldehydes and ketones, okay. So aldehydes are generally more reactive than ketones. When you are comparing aldehydes and ketones, so aldehydes are more reactive as compared to ketones in the nucleophilic addition reaction. So when we are comparing which will undergo nucleophilic addition reaction more easily is the aldehyde. Okay. So aldehydic, that is nucleophilic addition reactions are more reactive in case of the aldehyde. They are generally more reactive towards nucleophilic addition reaction, your aldehydes, okay? And why ketones, they show lower reactivity, reactivity, there are two reasons. The first reason is that because ketones will have two alkyl, right? Aldehyde is like this. Okay, why ketones, they are not more reactive? Because you can see that both the groups present beside the carbonyl group of what? They are alkyl groups, right? They are both alkyl groups. So because of that, what will happen? There will be steric hindrance. Okay, there will be steric hindrance. So because of the steric hindrance in the ketone, so they are less reactive. And also there is a plus I effect. So because of the presence of the alkyl group here, what will happen? There will be plus I effect will get increased on the carbonyl carbon. So plus I effect will be more on the carbonyl carbon. So partial positive charge on carbon will decrease. So as a result, because of the presence of this alkyl group, there will be partial positive charge on the carbon. So because of this, what will happen? The charge which has to be that is a year, there will be development of partial charges. So that will go on decreasing. Okay, this will go on decreasing. So these are the two reasons why ketones are less reactive towards the nucleophilic substitution, nucleophilic addition reaction. Okay. So So this is the first example of nucleophilic addition reaction. Okay. So what we are doing, we have a carbonyl carbon, and across this carbonyl carbon, we are going to add a cyno group. So cyno, our nucleophile is what? Our nucleophile is a cyno group. So cyno will attack. Okay, the cyno group will attack on the carbonyl carbon, the partial positive charge, it will change. And what you are going to get? You are going to get a cyanohydrine. Okay, you're going to get what? You're going to get a cyanohydrine. Okay, so this is a cyanohydrine. Now this, okay, this is a tetrahedral intermediate of cyanohydryl complex. And then what you're going to get is, then the alkoxide, whatever is formed, that will get attacked by a proton. Okay, it will take up a proton and it forms a cyanohydryl complex. Got it? So this is the addition, one of the addition reaction. So you all take this as a aldehyde. Okay, take this as aldehyde and try to uh, write the addition product for this. Yes, what will be the addition product? So what we are doing here, we have to follow the mechanism. Okay. So ketones, okay, when ketones or aldehydes, when they react with that is your hydrogen cyanide, that is HCN, okay, they should yield you a cyanohydrines. Okay. Now, when we compare, so just now what we have seen that aldehydes and ketones both can undergo nucleophilic addition reactions. But which is more reactive? Aldehydes are more reactive as compared to that of ketones. So why ketones are less reactive? What are the two reasons? We have seen two reasons. The first reason is what? Uh, okay, the first reason is to the carbonyl carbon, both the groups attached are alkyl groups, right? Both the groups attached are the alkyl group. So because of the presence of alkyl group, there is a steric hindrance. Steric hindrance is there. So because of steric hindrance, because they are a bulkier groups, so there will be steric hindrance. So so this is the first reason. Okay, this is the first reason. So because of that, it is less reactive. Second reason is that again, due to the presence of both these alkyl groups, there will be plus I effect, more plus I effect. So as a result, what will happen? Okay, as you know that on the carbonyl carbon, there will be development of partial positive charge and this will be partial negative. Why? Because carbonyl carbon is a highly polarized bond. Okay, it is highly polarized bond. So as a result, carbon will get a partial positive charge and oxygen will get a partial negative charge. So, but what happens due to the presence of these two alkyl groups or aryl groups, there will be plus I effect, and what will happen? The partial positive charge, it will go on decreasing. Okay, it will go on decreasing. So, because of that, again, the ketones are less reactive. So these were the two reasons. Now what we are discussing how these, so these are, we have a carbonyl carbon. Okay, we have a carbonyl carbon. Now this carbonyl carbon, what we are going to do? We are going to attack it with a nucleophile. So if this nucleophile will attack this carbonyl carbon, there will be polarization of this bond. And what it forms? It forms a C, right? Then Nu minus. Okay, and O minus, not Nu minus, Nu and O minus. Okay, so this is a intermediate product. So this will undergo a slow step. Now in the second step, what happens? Whatever the, this is there, okay, your O minus, so that will attacked by a proton. So this will, O alkoxide ion will attack the proton and it forms a addition product. Okay, it forms an addition product. So like this, we are going to take different nucleophiles now. Okay, so now suppose I have taken now OH. I have taken here Cn, not OH. So if I take here Cn minus, okay, HCN is given. HCN, when it gets decomposed, it will get into H plus and Cn minus. So which is our nucleophile? Our nucleophile is Cn minus. So Cn minus will attack the carbonyl carbon and thus the polarization of bond takes place. Now what will happen? Instead of Nu, there will be Cn. Then here again, instead of Nu, what it will be? Cn. Okay. Now attack of this takes place and what we get is, we are going to get, sorry, this is OH only. OH. Okay. Here what we are going to get? We are going to get a, what is the product name? It is cyanohydrine. Okay, we are going to get cyanohydrine. Now similarly, I had given you example. Alright, what was the question? I give you a acetaldehyde CH3 C double bond OH. Okay, we have a acetaldehyde. We are react to it HCN. Now HCN again, when it gets, it will split into H plus and Cn minus. So which is the nucleophile? The nucleophile is the Cn minus. So let me take the nucleophile Cn minus. So what will happen? The Cn minus will attack the carbon and as a result, partial bond will be polarized. Okay, bond will be polarized. What I'm going to get? CH3, CH, then O minus and Cn. Okay, now this is a slow step. Now in the next step, what happens? Next step, what happens? Whatever the, this is there. Okay, let me write it in the one step only. So this is a slow step. Okay. Now here, what will happen? Attack of H plus takes place. Right. So here, your O minus will attack this H plus and we are going to get CH3, C, H, OH, and Cn. Okay, so this is what? This is a cyanohydrine. Okay, cyanohydrine. Acetaldehyde, acetaldehyde, cyanohydrine. Acetaldehyde, cyanohydrine. Okay, so like this, we are going to get the product. Like this, we are going to get the product. Is it clear? Is it clear
Yes,
now? Okay. Okay, fine. So next we are going to discuss the addition of sodium hydrogen sulfide. So we are going to do different nucleophilic addition reaction. So next we have sodium hydrogen sulfide, NaHSO3. Okay, NaHSO3. Now when you have NaHSO3, okay, our NaHSO3. So NaHSO3, it will split into Na plus and SO3. Okay, SO3H minus. Okay, SO3H minus like this. Now here, what will happen? Which is our nucleophile? SO3H minus. Okay, SO3H minus. Now again, let us see the reaction. So we have a carbonyl carbon. We have a carbonyl carbon. Then we are going to react it with sodium hydrogen sulfide. Now sodium hydrogen sulfide. Okay, when it reacts with NaHSO3, so which is our nucleophile? It is SO3H minus. So what will happen? SO3H minus will attack the carbonyl carbon. Okay, and polarization of bond takes place. So this is a slow step. Okay, this is a slow step. What we are going to get? C. Then we are going to get O minus and SO3H. Okay, so this is the intermediate product. Now this will undergo a fast step where it has to attack the proton and you're going to get what? You're going to get OH and SO3H. Okay, so we are going to get what? Acid, this is a bisulfide addition product. Okay, so bisulfide addition product. Bisulfide addition product. Now I'll give you a this. You have to do it on acetaldehyde. So take a acetaldehyde compound, okay, and react it with NaHSO3. Okay, tell me the answer. What will be the answer? Yes, try. Right. So this is a slow step. Again, it will go a fast step where the alkoxide will attack this. And what you are going to get? CH3, COH, H and SO3H. Okay. So what is the name of this? It is a acetaldehyde sodium bisulfide. Okay. Acetaldehyde sodium bisulfide. So it is SO3Ne. Okay. Mm, so NaHSO3 giving you Na plus SO3H minus. So when it goes a slow step, what we are going to get? Na plus, and here SO3H. Now what in here only there will be proton transfer. Okay, proton transfer will take place within the same compound, and we are going to get what? We are going to get the COH and SO3Na like this. Okay, fine. So based on this, let us solve now. CH3 H double bond O plus NaHSO3. Okay, now you can tell me the answer. So first it will undergo a slow step. Okay, so attack of this will take place on the carbonyl carbon and polarization of bond takes place. Next step is what? CH3, CH, then this is O minus, Na plus. Okay, and here what you are going to get? SO3H. Fine. Now here what will happen? The proton transfer takes place. Proton transfer, and what you are going to get? I'm going to get CH3, CH, OH and SO3Na. Okay, so what I'm going to get? I'm going to get acetaldehyde sodium bisulfite. Acetaldehyde sodium bisulfite. Is it clear now? Is it clear? So similarly, do it on acetone and C. What will be the last? You have to tell me. Acetone, CH3, C double bond O and CH3. Do it on this compound plus NaHSO3. Yes, try. Yes, what is answer? So acetone reacting with NaHSO3. What did you get? So first is the slow step. Attack of this will take place on carbonyl carbon. Polarization of bond takes place. So C, CH3, CH3. Okay, so this is becoming O minus and this will become SO3H, O minus, Na plus. Okay, now it will undergo proton transfer within the same molecule. Okay, so what we are going to get? C, CH3, CH3, OH, SO3, Na. So again, what we have got? Acetone, sodium, bisulfite. Acetone, sodium, bisulfite. Got it? Is it clear up to here? Is it
Yes,
clear up to
ma'am.
here? Okay. Others, any doubts? You can ask me here itself. Any doubts about the first nucleophilic addition reactions? Chemical property. First one is chemical property is the nucleophilic addition reaction. Okay. Now next we are going to discuss is the next is with Grignard reagent. Okay, let me take a blank slide. Okay. Next one is with that is so for a first example, what we have seen, addition of hydrogen cyanide. Okay, addition of hydrogen cyanide to carbonyl carbon. Second was addition of sodium hydrogen sulfide. Third one is addition of Grignard reagent. What is Grignard reagent? What is Grignard reagent, students? What is Grignard reagent? RMGX. Right? Organometallic compounds are called as the Grignard reagent. So what we are going to get? So aldehyde and ketones, again, they react with the carbonyl carbon to give you what? To give you addition compound, okay, which on hydrolysis will give you alcohol. So let us see. So this is a carbonyl carbon. Let us react it with RMGX. Okay, let us react it with RMGX. So R in RMGX, your Mg is partial positive charge and your alkyl group is partial negative charge. So as a result, what will happen? Yes, what will happen? Your this will attack on the carbonyl carbon and your the polarization of bond takes place. So what you are going to get? I'm going to get C. Okay, then O minus and O minus and your R. So here O minus and MgX will get added. Okay, O minus MgX. This will undergo further hydrolysis. Okay, it will undergo hydrolysis to give you what? To give you OH R plus MgX and OH. So this is the alcohol. Okay, this is our alcohol. So we are going to get what? We are going to get alcohols. So this is a reaction. Okay. Similarly, let us take now formaldehyde. Let us take formaldehyde as our aldehyde and take your Grignard reagent. Let me take R as CH3 and X as iodide. So it will be what? It will be methyl magnesium iodide. Okay, methyl magnesium iodide. So this will get partial negative, this will get partial positive charge. Okay, so what will happen? So your Grignard, your this will attack at the carbonyl carbon and the polarization of bond takes place. Okay, so carbon, hydrogen, hydrogen. Here will be your O, Mg, I, and here will be your CH3. This will undergo hydrolysis to give you H, C, H, O, H, CH3 plus Mg, OH and X. Sorry, X is your iodide. Okay, X is your iodide. Got it? So this is what? This is a ethyl alcohol. This is ethyl alcohol. So whenever you react it with Grignard reagent, okay, you react it with Grignard reagent, you're going to get what? Aldehyde. So whenever you have carbonyl carbons, okay, whenever you have a carbonyl carbon and you react it with Grignard reagent, what you're going to get? You're going to get a alcohol. So important, marks it as important, addition of Grignard reagent, important. Okay, important. Okay. Now, next one. Next one. Take one more example. So this is the first example. Let us take one more example. So we have taken now acetaldehyde. Okay. So let us take acetaldehyde. Acetaldehyde plus again the same methyl magnesium iodide. Okay. Solve it and tell me the answer. As I'm solving, you all also solve and tell me the answer. So what will happen? It will attack this and polarization of bond takes place. Yes. What is the answer? So carbon, CH3, H, O minus, sorry, O, MgI, and here is your CH3. This will undergo hydrolysis to give you C, CH3, H, OH, CH3 plus MgOH iodide. Okay, so what is the name of this? 1, 2, 3 carbon. So it is a propane to all. Okay, we are going to get propane to all. Okay, then, so this was what? First one was a formaldehyde, second one is the acetaldehyde. Now next one, let us take next one. So I'll take a ketone now. So I'll take a ketone. Let me take a ketone now. Plus same methyl magnesium iodide. So this is partial negative, this is partial positive. So this will attack on the carbonyl carbon polarization of bond takes place. So CH3, CH3, OMGI, and this is CH3. Okay, can you tell me what will be the product? Yes, after hydrolysis, what will be the product? Yes, right. P, CH3, CH3, OH, CH3 plus MgOH and I. Okay, so this is what? This is a tertiary butyl alcohol. Okay, can you tell me what type of alcohol it is? This one, whether it is a primary alcohol, secondary alcohol, or tertiary alcohol? Yes, students, what type of alcohol it is? The last one, what is the whether it is tertiary alcohol, secondary, primary, what is the yes, yes, what is it? It is a tertiary alcohol, right? This is a tertiary alcohol, and here carbon and carbon, right? So this is a sorry, here it is no. So carbon, carbon and carbon. So carbon is attached to two other carbons. So this is a secondary alcohol. Here carbon is attached to other three carbon atoms. So this is a tertiary. This is secondary. This is primary. So what you can see here. So whenever carbonyl carbon, okay, whenever the Grignard reagent is attacked by your formaldehydes, okay, formaldehydes, then it will give you primary alcohol. So whenever formaldehyde reacts with the Grignard reagent, it will give you primary alcohol. Then except your formaldehyde, other aldehydes when you take, okay. So except your formaldehyde, so I'm talking about second now. So except your formaldehyde, if you take any other aldehyde, then I'm going to get what? I'm going to get a secondary alcohol. Then except then all the ketones, okay, all the ketones you are going to get tertiary alcohol. So with formaldehyde only, you are going to get primary alcohol. Except formaldehyde, rest other aldehydes will give you secondary alcohol, and ketones will give you tertiary alcohol. Is it clear? Is it clear? So practice this. Okay, practice this. Very important. Addition of Grignard reagent. It is a must question, asked question in the exam. Okay, so they may ask you to prepare tertiary butyl alcohol from Grignard reagent. Like this, the question is asked. Prepare tertiary butyl alcohol from Grignard reagent. So like this, the question is asked. Okay, so you have to be ready. So they will not give you these steps. Okay, you have to write. So what you have to do, how you know tertiary butyl alcohol will be, how you will get tertiary alcohols by taking a ketone. So you have to see which ketone you have to take ketone. Then you have to react with the Grignard reagent. Then you are going to get the addition product that upon hydrolysis will give you tertiary butyl alcohol. Is it clear? So this is the third type, that is addition of Grignard reagent. So practice this compounds. Okay, practice this. So this was the third type. Now the fourth type is addition of alcohols. Okay, the third type of nucleophilic addition reaction is fourth type is addition of alcohols. So aldehydes or ketones, when they react with alcohol in the presence of dry HCl, it gives you hemiacetals. It gives you hemiacetal. This hemiacetals further reacts with alcohol to give you hemi. Okay, so when this hemiacetals, okay, when they further react with alcohol, they give you gem alkoxy compound, which is called as acetals. So these are called as what? These are called as acetals. Okay, these are called as acetals. So what happens here? You have a aldehyde. So aldehydes, they will react with the alcohol. So let me show you. So I'll take a aldehyde now. This is aldehyde and I'm going to react it with the alcohol. Okay. So what will happen? This will attack here and the polarization of bond takes place. Okay, in the presence of HCl gas. So what I'm going to get H. Okay, because it is an aldehyde. So RCH, then O, mm, OH and OR dash. Okay, OR dash. Now here, what will happen? This will yield a hemiacetyl. Then again, this will react with one more molecule of alcohol. So what will happen now here? So R, C, H, O R dash and O R dash. So this forms acetals. So hemiacetals are converted to acetals by reacting with one more mole of alcohol. Okay, so this is the reaction, okay, addition product obtained when you react it with alcohol. So take homework, you do it with acetaldehyde. So take this as homework. Take acetaldehyde and react it with alcohol like ethanol, C2H5OH, in the presence of dry HCl and tell me the product obtained. Okay. So acetaldehyde is there and I've given you R dash OH as ethyl alcohol, that is C2H5OH. Okay, ethyl alcohol. Is it clear? Okay, so let's solve this in the next class. So any doubts up to your? Okay, fine. Others have any doubts? So please solve, okay? It might look little difficult, but if you solve, if you practice this examples, then only you will come to know. Okay, you have to practice. So for organic chemistry, practice is more important. So I've told you, please practice all those name reactions. Okay, so you have to read it. First read it, okay, understand, and then write it. First see and write, then without seeing you can practice. Okay, so unless and until you practice, you won't be perfect in the reactions. Fine. So anything you want to ask, any doubts? Yes. So we have few more chemical reactions and we have some name reactions. So let us see these all things in the next class. Okay, fine. So okay then, so I'll be ending the session here. Okay, and we'll meet on Monday. Fine? Yes. Thank you. Have a good weekend. Yes. Bye.